Welcome to day 30 of topic 3. We are in the midst of our kind of weird little small topic 3 unit of implicit differentiation. This is our third day of that. Inverses and related rates. So this is actually our last day of implicit differentiation, though we're really going to use it all throughout this unit and then off and on for the rest of the year. But these three little subtopics tie together well really through implicit differentiation. Before you get to day 30, I do have to tell you that you really need to have finished day 29, which is just a worksheet. I didn't make a video on it, though my full solutions are, of course, available on Teams, because we're going to focus pretty heavily on two free responses that that you started on day 29, hopefully finished on day 29, and maybe even checked my worked out solutions for those. Now, if you didn't check out the worked out solutions, but you finished those two free responses, then that's fine, because you'll just extend today a little bit, and I'll show you how right now. So we're going to be looking through some student responses, actual student responses from a couple years from the AP exam. And these student responses are to the two free responses that you guys worked through yesterday in class or maybe for your independent practice. So let's take a look at this first one. The first one, and in fact, I'm going to go ahead and just focus on one, and I'll bring that other page back in a second. We're going to go ahead and look at 2008 Form B. So you'll notice sometimes on some, especially these older free responses, they might have a form number. This Form B is essentially like version 2. Think Form A, Form B. There's actually close to 15 different versions of the AP exam every year. Form B is oftentimes given to students at a school who tend to score pretty well. They might give two versions of the exam instead of one, and those two versions, they might be testing a slightly different format of a question, different types of questions, and they're always scored in a similar way. So if a certain percentage of students do well on the first form, Form A, then the same percentage will do well on Form B, but there might be slightly different cut scores. So if you are talking to students and they're like, wait, I didn't have that problem, I had something else, then it's actually probably a good thing. It means your school's doing pretty well in terms of AP responses and you've gotten a separate form. So this is Form B. This is like version B. And you had to work through a couple of these on your own. Now, if you already checked your work, then you can easily skip this part and move on, but you might as well listen to me. If you haven't checked your work yet, though, you will notice that there are 4 questions, A, B, C, and D, and this is what our common scoring rubric looks like for these 4 questions, or these 4 parts to one question. They have very basic work over on the left, and then they have the number of points on the right, and you should, of course, notice if you total up these number of points, 2, 2, 3, and 2, that it adds to the same number of points that every free response on the AP Calculus exam sums to. It adds up to 9 points, right? There are 6 free response questions on an AP Calculus exam. Each question is worth 9 points. 9 times 6 gives 54 points for the second half of the test, the free response portion of the test. These descriptions over here are pretty darn vague about how you get those points. 1 point for implicit differentiation, 1 point for verification. When you actually score these, and I have scored in the past for the AP College Board Syndicate, they give you a big long packet. You're only in charge of one question, so I might have just scored, say, question 6 for all the students that took it. I wouldn't get every student, that's way too many, but I would only be in charge of scoring question 6, and I'd get a really in-depth look, and they'd basically say, here are the 2 points. Oh, by the way, though, in order to get this first point, here's exactly what they needed to show somewhere. Here are 20 different ways that they could have gotten the first point, much more in-depth. But they don't release those to the public, just as a heads up. Also, I was not scoring AP exams in 2008. I was in college in 2008. So I do not have the extra scoring notes here. However, what I would like you to do, if you haven't scored yourself, is to please go through and score your problem 2008 Form B question 6 from last class from day 29 and see how you did out of 9 points. And if you already did this, then that's fine. You can just skip on. So hopefully at this point you've scored, and I'm curious if you guys have any questions. One question I get asked very commonly is on this second problem. They say, well, this tangent line equation, mine didn't look like that. You taught us to write it in HK form, so we said t of x equals 1/4 x plus 2 plus 1. Is that allowed? Of course, it says tangent line equation. It doesn't say tangent line equation in a specific form. If you have an equation here that when you graph that equation creates the correct line, then you have done it correctly. It doesn't matter what form it's in, mx plus b, standard form, HK, point slope form. Any of those are all fine. Okay, let's see, what are some other good questions that come up here? I think there's probably nothing too much. So let's go ahead and see how well you understand this rubric and how well you can read through other students' responses. So what you have on the next couple pages of your packet are these wonderful, are these wonderful student responses here that we have version A, or I guess student A1. Nope, that's not it. We have the first student, right here, which we're calling student A. Student A page 1, student A page 2, and then we have student B page 1, B page 2, and C and C. So 3 students here. Your goal is to take this rubric and score each of these students' free responses and see how they did out of 9 points. I will tell you that they all got different scores and none of them received 0 total points. All right, so you have some time now to take the rubric, go through, see how they did, write all over this. If you would like score them, you can say, oh, this is 1 point here, 1 point, oh, they didn't do that, they lost a point, so on and so forth. And then once you're done with that, I'm going to go ahead and split screen this, and I'll even do it right now. I'm going to split screen this, and I'll actually show you how many points each student earned and why. And so we'll go back and talk about the why later on. So pause this, go through, score those 3 students, see how they did out of 9 points, and then we will compare. Okay, hopefully you've scored everything at this point. I'm going to go ahead and show you how those 3 students did. We had student A, student B, and student C. Here are the results. Student A received all 9 points. Okay. Student B received 6 points, and student C only received 4. So let's make sure we're comfortable with that, and we're just going to quickly skim through these and see if you had any questions. Nothing weird, I think, on part A. Part B wasn't bad. Notice that they wrote this in point slope form. They could have stopped right there. In fact, I would have stopped right there. However, they went further, they distributed, and in their head they were able to convert it to slope intercept form. That's awesome. Either one of those would have earned full points. I certainly would have left this off. That's way too much work, and there's a very good chance you could have made a mistake with those fractions. All right, the third one. They did very well here. They went through, they solved. I don't think there's anything confusing at that point. So then we need our fourth one. You should notice, though, that they do give a quick explanation of what they're doing every time, and I think that's a really good idea, right? Don't just start off for example, part C said, find all points where the tangent to the curve is vertical. Well, don't just start by setting the denominator equal to 0. I think it's a very, very good idea to explain why you're setting the denominator equal to 0. You might have gotten full points for this. However, it's never a bad thing to show your starting point and the reasoning for the starting point, right? On an AP exam, you always have to show a setup and a conclusion for every equation that you're solving, which means that you couldn't have just done this and then gone right to here, because you didn't show a setup to the equation you were trying to solve. You were trying to solve this. You could have shown this and then actually gone straight to there. That's fine. They don't care about the in-betweens, but every equation that you're solving, you need to have seen the equation somewhere and then shown the solution. Right? And then the last one I thought was very well done. Nothing too bad. I assume there are no questions there. There usually are not. Let's look at our second one. Okay, now the scoring for this question was 2, 2, 3, 2. So they earned 2 points in part A. That's good. It means they got a perfect score there. Nothing bad. You'll notice that they use y prime in here. There's nothing wrong with that. The graders are going to know that y prime is the same thing as dy dx, so don't let that throw you off. I like dy dx a little bit more. I think it helps maintain what the independent versus dependent variable is, but totally up to you. Part B, they received 2 points, so nothing bad there at all, right? They also took the bold approach of converting it to slope-intercept when they could have stopped much earlier. Don't do that. Stop early. However, Part C, they got no points. And it's interesting because on no points, there were 3 points allowed on this, I think, right? 3 points allowed, and I'll pull the rubric back up at the top. And the first point... Stop it. The first point says y equals -1. So there wasn't actually a spot on here where they said explain what you're going to do. And it's interesting because really their explanation is a pretty good one. If they knew that if a tangent line is vertical, it means the tangent line has an infinitely large or infinitely small slope. However, they didn't realize how they would tackle it from here, so that's probably not a great way to go. So they definitely would receive 0 out of 3 on this one. Okay, and then we jump back to our last one. Let me jump down to our scores again, right here. Very nice. No points, and then they receive full points in Part D. Right? So Part D looked pretty darn good. They explained things, they solved, they did a really nice job here. No complaints. All right, Student C. Student C, 2 points in Part A. They all did the implicit part very well. Only 1 point in Part B. Why did they receive only 1 point in Part B? Well, let's take a peek. In Part B, the student makes an error calculating the slope, so they don't earn the first point. However, they used the incorrect slope and gave a tangent line, which did give the second point. And I think that's really important because people might be tempted to say, oh, they made a mistake here, right? Silly mistake here. But then they already penalized them for getting that wrong. So what you have to think is, if they got that right, would they have gotten the rest of the problem correct? And yes, they would have. Everything else about their problem is right. So why take off a point here and then here again if they already got penalized for that? This is like that double jeopardy thing where they already got the 1/2 wrong. Now we're just going to assume that 1/2 is the right slope and use it all the way through. So they actually get 1 out of 2 points here, which is very, very nice. And that's true for most AP exams and most problems, where if you get a wrong answer but you continue to use that wrong answer, you're not penalized again. The only exception is if your wrong answer isn't, quote, complicated enough, end quote. And one of the most common things that I see is someone will get, instead of a slope of like 1/2 or 1 or -1, they'll get a slope of 0. Generally, if you get a slope or if you get an answer of 0 and continue to use 0, and 0 is wrong, you probably won't receive any further points, because what does 0 do if you're using it in an equation, especially through multiplication? Well, 0 just eliminates the thing it's multiplying by. It simplifies the equation too much, and sometimes 1 is that too. So if you're really not sure, guess a number that's not 0 or 1. 2. -2, something like that. But yeah, if you're not sure, don't continue to use 0. Because generally you won't receive that continuing point, that double jeopardy point for using an incorrect answer later on, because 0 is just not complicated enough. It overly simplifies the problem. All right, they only receive 1 point in Part C, but let's take a look at that. 1 point in Part C, where did they get that 1 point? Oh, well, it looks like they set the denominator equal to 0, or they got that y cubed equals -1, and that was pretty darn good. Honestly, I think that was probably the hardest part. However, they didn't do the rest, because they asked them to find the points, and they weren't quite sure how to find x, and they needed to go back to the original equation, right? And then they don't receive any points in Part D. Okay, it says no because it doesn't touch the x-axis. Well, and it's funny, they're right, but they're never going to get these points for a couple of reasons. First, they talked about it. What doesn't touch the x-axis? The tangent line, the graph, dy dx. Anytime you use it in your answer, you need to take a look at your life and self-reflect and go, I've made a terrible mistake. It is always too vague on any AP exam. Never use it. Now, maybe they said because, and notice they misspelled because. This is not a spelling test, right? They used the wrong it's earlier on too. It's okay. We're not judging them too much out loud. Because it does not touch the x-axis, because maybe the original curve does not touch the x-axis would be better. Now, would they receive any points if they put that? No, because the question would be how. We only have the equation, and if you know the curve doesn't touch the x-axis, you better prove it to us. Second, we have an answer with no setup. And if you get an answer with no setup, for example, if we jump back to here and they said y equals -1, and then they went on to use that, no points. You need to have the equation set up and the answer. If you don't have both, you won't get the point. And that prevents people from just randomly guessing an answer and getting a point for it. You'll never get that on the AP exam. You can't just say, I don't know, maybe I think it's 7. Even if it is 7, 0 points. Because it's all about where did you start from and then how did you get to the answer. They don't care that you got the answer right by guessing. You need to have proved to them that you knew the right work to get there. Okay, so I think that probably does a pretty good job of going through a few things here. There's probably one last important piece to talk about, and that's their scores here. Right? Let's talk about that score of a 9. That is a perfect score. I graded, I don't know, 600 of the same free response this last year, and I had 0 perfect scores. A perfect score is extremely uncommon. In fact, even a score of a 6 is very uncommon. Usually what they say is that if you want to get a 5 on an exam, actually we should go a 3, a 4, and a 5. An AP score of a 3 is usually passing, a 4 and a 5 are above passing. Usually they say if you want a 3, you want to average 3 points on every free response. If you want a 4, you should shoot for 5 points, and if you want a 5, you should shoot for a minimum of 7 points. Now, when I say shoot for, of course, everyone's shooting for 100% points. But you need to realize that if you are going for a 3, and you should again shoot for a 5, but if you're going to earn a 3, that's really like 1 point for each problem. And ask yourself, could you have gotten 1 point for every problem here? I hope so. I hope you could have at least seen a starting point or maybe gotten more than 1 point on one, and then you're doing just fine for a 3. Right? A 5 is pretty hard to shoot for. 7 out of 9, that's like a 78%. You can even argue that you could get 6 points on each one and still probably pull off a 5, but a 7 is more of a safety net. Realize, though, that this 3 is very, very attainable for anybody here. All right, let's move on to our second one. Our second problem is the second free response that you guys had last night. You need to realize, though, that, and again, I'll get rid of my split screen here, that one of these is cut out from what we had you do, and that was on Part C. Part C is worth 4 points. However, there is no last point here because we don't know how to do that yet. We don't even know what this means, right? Does the curve have a local max, a local min, or neither and justify? Well, I just took that part out when I gave you the free response. So strangely, this one's going to be out of 8 points instead of 9. However, you'll still be able to grade everything, no problem. So don't worry about that last one. Just look at the other 8 points and see how you can do. So your goal is to figure out how did the students do out of 8 points. We again have a student A, a student B, a student C. The scores are not in the same order this time, so it's not going to go 9 and then 6 and then 4, something like that. So see what you guys can do with it, and then again, unpause me, I'll split screen it, and we'll see how you did. All right, so you're back. Let's go ahead and see how everybody did. I'm going to pull up the answers here, right? So we have student A, we just have student A and student C this time. Student A did again earn a 9, and student C actually earned 7. So both of these are extremely high scores, right? Very, very uncommon. Let's go ahead and see what we can do. And in fact, maybe it's worth even reading what they tell us here. So let's undo the split screen and see what we can do. Okay, students were given in Part A, they needed to use implicit differentiation. Part B, horizontal tangent when the derivative is 0. Part C, they probably had to use the quotient rule, and then ignoring the rest. All right, let's get to it. You'll notice that there were, again, 2 points for Part A, very common for implicit differentiation. There were 3 points for Part B, and I think Part B actually is a little bit tricky there. And then Part C is actually 4 points, and they got 2 points for getting a correct second derivative. Those 2 points are an interesting allocation. Usually it's you get it all right, If you make one mistake somewhere, you can get 1 out of 2 points. And if you make more than one mistake, it's usually 0 points all the way through the rest of the problem. Even if you miss one of these 2 points, a lot of times you won't be eligible for the last point. That's just the way their double jeopardy goes. And their reasoning wise, if you made more than one mistake somewhere on the way through, it probably throws off this problem enough that it's just the rest isn't going to make any sense. But again, it varies year to year. There's no one rule for it. So let's go ahead and see how they did. So first one, they earn all points. They did very well here. Okay. For part B, look at this crazy amount of work. Notice they went through and used the quadratic formula. Let's see, how did they get there? Well, they determined that at x equals 3, y equals 2 or 1/4. Well, they got x equals 3 just from the problem, right? They told us that. So they evaluated this equation at 3, got here, set this equal to 0, and said, oh no, I don't know how to factor, which is okay because they remembered their old favorite friend, the quadratic formula, plugged everything in, simplified down, and got this as their 2 answers. Bravo to them. There is never a case where you have to use the quadratic formula on the AP exam. There are other ways to do things, and if you find something that can't factor, then it either means you did something wrong or there's probably no solution there. So what did they do from here? Well, they took these two, right? They said, oh wait, let's just set the denominator equal to 0. We found y equals 2. Sounds good to me. And then they even checked their work at the very end. I thought that was very clever. You'll notice if you try 1/4, it does not work out equaling 0 down here. Okay, and then our last part, they went through and they needed to find their second derivative. They did a very nice job here. I think what they actually did is they went through and they used the product rule here, and then they used another product rule over here, and then they went through an isolated y double prime. Now, realize that the result for y double prime right here is the same result if they had isolated y prime first, right? They had it over here. If they had just done the quotient rule, they would have gotten down here. That's probably much more efficient. They didn't do that. That's fine. They multiplied this by y prime and decided, I want to go through and use a bunch of product rules. Cool. Good for them. They get the answer. They substitute everything in. I love that they showed what y prime is equal to, and they went through and gave their answer. Super nice, a lot of extra work, however, wonderfully apt student. Let's look at our second part. Okay, our second part, this says show, not snow, I promise. This second part, they do get both points in part A. They use that dy dx notation. They only get 2 points in part B. And can you see what they did here? On part B, they took this 3, they substituted into the derivative, and they found that the point that makes this derivative equal to 0 is the point 3, 2. But do you see their mistake? Sometimes the derivative lies to us, right? Think of the case where you said the natural log of, if you were given the equation y equals the natural log of x, and you get y prime equals 1 divided by x, and then let's say you looked at this equation and said, I want to know the slope at -2. Well, that's -1/2. Super cool, but is that relevant to this original equation? Well, no, it's not, because sometimes the derivative will show more than what's on your equation. So after we get to this point 3, 2 just from the derivative, we need to remember, wait, is that point actually on the original equation? So that's where you need to go back, replace your x's with 3, your y's with 2, and make sure that whatever's on the left side is equal to the right side. And they didn't check that, and if it turned out it wasn't on there, they'd be really confused. All right, and then let's take a look at our last one. Our last one, they get 2 points for using the quotient rule correctly, and I love that. This is probably how I would have done it exactly. And then from here, they did have to plug in a point, right? So let's see. They made an error when simplifying. Simplification, the killer for everybody. Let's take a look. So they plugged everything in here. If they had stopped right here and they didn't write all of that, full points on the problem. But the issue is that they went here and they simplified down, and this is not the right simplification. This 4 apparently just got up and ran away somewhere. Very sad. And because they circled this answer, and this answer, what they end up doing is they say, wait, they circled two answers. Which one do we grade? Well, they actually take the number of points that each one's worth, and this is worth 1 point, this is worth 1 point. They're worth the same 1 point. Well, this would have received 1 point. This would have received 0 points, and then they average the score together. Like, okay, 1 point plus 0 points divided by 2, there's 2 of them there, gives you 0.5 points, and then they round down. So when they end up getting 1 point and 0 point, they average, okay, this is 0.5 points because they circled two different answers. Well, then we get 0.5, so we round down. They get 0 points for this. And honestly, that's generally what ends up happening. If you circle two answers that aren't the same, you usually end up getting 0 points for the answer. So even though this is right, and again, if they had stopped right here, they would have gotten the point. By circling an incorrect answer, they lose the point. So can you stop here in my class? Yes. However, I expect more of you, and so on your free responses up until we start really preparing for the AP exam, I do expect you to try and simplify. So don't think you can get out of it. There are certain cases where you do have to simplify, especially on the multiple choice. So thank you for sticking through all of this, and hopefully you got a few things out about the AP exam. If you have any further questions, you can always ask me in person or email, and I look forward to coming back and working with you when we get our last set of derivative rules, our inverse trig functions.